Today, we extract the domain name from a URL string, create a formatted phone number string from an array of integers, and then we take a trip with Granny to see her friends, only to get lost in the Pythagorean Theorem and come home a lot later than expected. Hello world, and this is versus Codewars. We begin today with a function that, given an array of 10 integers between 0 and 9, returns a phone number string formatted as follows: XXX in parentheses, the first 3 digits, a space, the next 3 digits, a dash, and then the last 4 digits right here. Let's go ahead and get started here. First, we need to filter out any numbers that are less than 0 or greater than 9. Let's do that by doing this. Const filtered numbers equals number array. We're going to run it through filter, pass in our number into the predicate function, and we're going to return true if return number is greater than or equal to 0 and number is greater than or equal to 9. Alright, we need to see if the length of this filtered numbers array is exactly 10. If filtered numbers dot length, or rather maybe greater than or equal to 10, because we'll only be working with the first 10 numbers. We won't be actually, yeah, it does actually need to be exactly 10. So if filter numbers dot length is not equal to 10, we'll just go ahead and return a blank string. Now, what we'll go ahead and do, we're going to format the numbers in this array into a phone number string. First, since the numbers are in array form, we need to join them together into a string. And then what we'll go ahead and do, we're going to use the replace method. We're going to use a regular expression with the replace method to actually, instead of replace substrings with other substrings, we can go ahead and use this to create a formatted string using regular expression capture groups. Alright. What we'll go ahead and do here is, for the first argument, we got our regular expression here. We're going to start the string. We're going to have 3 capture groups, and then we're going to end the string with the $sign right here. In the first capture groups being denoted by these parentheses here, we're going to do this character class here, which catches numbers, and then in these braces, we're going to put in 3. What we're telling our regular expression here to do is find exactly 3 instances of a digit. All right, we're going to do the same in the second capture group. And then in the third capture group, we're going to do that very same thing again. This time, we're going to look for 4 digits. All right, now that we have our regular expression set up, we can actually use these capture groups to make a formatted string, and we'll do that by doing this. In the string that we would usually use to replace substrings with, we'll instead do this. In parentheses, in our parentheses, we're going to have a capture group 1. Now, the first 3 digits of our phone number will be in this first capture group. They should end up in this string right here. And then space, capture group 2. In our replacement string, these $signs and digits correspond to the positions of our capture group in our regular expression. And then -3. All right, let's feed this into Node to see what this looks like. I've got this array of 10 integers right here. All right, I'm going to do node create phone number.js. And as you can see, we have our formatted phone number right here, 12345678890. Call now. All right, let's go ahead and feed this into Codewars here. And try submitting it. And we are good. Capture groups can be used to remember matches picked up by a regular expression. In the case of the JavaScript string objects replace method, those matches can be recalled in the replacement string using a $sign and then the index of the match, base 1. Keep in mind, though, capture groups have a performance penalty, so if you do not need to recall those matches, you can place a question mark and a colon just after the opening parenthesis starting the capture group to make it into a non-capture group. Given a URL string, the goal of this kata is to parse out the domain name that comes just before the top level domain in the URL. Let's go ahead and get started here. Alright, first we need to go ahead and find out if this URL has a protocol part before it. Let's go ahead and find out if this URL string has this part here. This part usually always comes after the protocol part of our URL string. Const post protocol index. We're going to go ahead and set that to url.indexOf ://. And we're going to use this index to calculate the start point of our URL. Const start point equals if post protocol index. We're going to be using a ternary operator here. If post protocol index is not equal to -1, that means our index of method found the start point of this string right here. So we'll just go ahead and do post protocol index plus 3, I think. Otherwise, we'll just go ahead and do 0 for our start point, because if this returns -1, then this method could not find this substring here. What we'll go ahead and do from here is we're going to look for the dash right after this primary domain name here. Const next slash index equals url.indexOf this / here, and we're going to start from our start point here. Next, we'll use that index to create a substring that will catch this domain name here. That's the domain substring equals if this slash here was not found, or rather, if this slash here was found, we'll go ahead and do url.substring starting from our start point and ending with the next slash index. Otherwise, we'll do url.substring start point. We're going to go ahead and console.log that and see what that looks like here. Domain substring. Feed that in a node. Okay, might help if we actually add 1 to this post protocol index. Or rather, I'm going to console.log the next slash index here. Oh, right. Okay. That should be a -1 and not a 0. Alright, that should be correct. Now, based on some of the log values in these tests, in the random tests shown in this kata, I think I can safely assume that no subdomains are being used in this kata, and that just www may be used. So, with that being said, what we'll go ahead and do is we're going to split this domain substring with a period. Call it domain parts equals domain substring split with a period. And what we'll go ahead and do is we're going to return either the first or second element of that resulting array, depending upon what this first part here looks like. If we're going to return if domain parts at 0 is equal to www, then we're going to return domain parts at 1. Otherwise, we'll return domain parts at 0. We're going to feed this through node here, and we should have our domain names here. Let's try this in Codewars and see what that gives us. Try to submit. And we are good. It's time now for the better solution of the day. I could have used 3 replace calls and then a split call to get our return value. The replace calls would replace the HTTPS, the HTTP, and the www dot and replace them with blank strings. Then I would have taken the resulting string and split it with a period and then return the first element to get our solution. I could take 1 replace call out and have 2 replace calls if I do the first one with a regular expression, https : :// and replace that with the blank string. That regular expression would have caught either HTTP or HTTPS because of the question mark after the S, which indicates an optional character class. Here we are helping out our granny. Given 3 arrays, an array of strings representing a group of granny's friends, an array of pairs mapping each friend to a town that they live in, and another array mapping each town to their distance from home, the goal of this kata is to calculate the total distance needed for Granny to visit all of her friends in the order specified in the first array. Let's go ahead and get started here. As you can see here, before we get started here, actually, I want to show you this console.log here. Alright, here is the group of friends right here. Here is the array of pairs mapping each friend to a town that they live in. But here is this third array mapping each town to a distance from home. Note that it is not an array of pairs. We're going to have to work our way around that here. And what we can go ahead and do that by doing this. We're going to go ahead and turn this into an object. What we're going to go ahead and do here is const distance table equals distances dot reduce we're going to set an accumulator and a value. Our initial accumulator is actually going to be a blank object. And we'll do return spread the current value of the accumulator object. We actually will need the index and the array that we are working with. We're going to go ahead and do I think it's index arr dot index. You know what? I have another idea actually. What we'll go ahead and do is I don't think reduce is going to work here. Let's go ahead and do our distance table. Then we're going to go ahead and run for let I equal 0. I is less than distances dot length. I plus equals 2. Because we're dealing with pairs here, we don't want to increment by 1 here. We want to increment by 2. What we'll go ahead and do is distance table at key distances at I equals distances at I plus 1. All right, we're going to go ahead and console.log that and see what that looks like. This table. Feed that into Node. And we have a nice formatted JSON table mapping each of our towns to their distance from home. A lot easier to work with than this, is it not? All right, let's go ahead and I think we'll go ahead and keep track of our current result here. The total miles covered, that is. I think instead of result, we'll call it miles covered. And this is going to be what's returned from our Kata function here. All right, what we'll go ahead and do here is we're going to iterate through each of Granny's friends here. What I think we'll actually go ahead and do, it might be a good idea. It can be fairly assumed that a single friend of Granny's isn't going to live in more than one town. So what I think we'll go ahead and do here, we're going to create a towns table as well. And we're going to do this somewhat the same thing we did with our distance table up here. For let I equals 0, I equals towns dot length plus plus I. We're going to do towns table at towns at index I, and in the array pair at index 0 equals towns at index I at subarray index 1. We're going to go ahead and console.log that to see what that looks like. And we have our nice formatted JSON table mapping each of Granny's friends to a town that they live in. From here, what we can go ahead and do is we're going to go ahead and iterate through each of Granny's friends for const friend of friends. Alright, we're going to go ahead and get the distance to this friend's town from home. Constant distance from home equals, you know what, we might need the index of the previous friend too. So what we're going to go ahead and do is, I think we should keep track of the friends visited thus far. Might be a good idea. Alright, for let I equals 0, I equals friends.length is less than actually friends.length plus I. We're going to go ahead and get that friend's town, and that town's distance. Const friend equals friends at index I. Const town equals town's table at friend. And const distance from home equals distance table at town. Now, first things first, if this array is empty, friends visited length is 0, then we can assert Granny hasn't visited any of her friends yet. We can just go ahead and add this distance from home to our miles covered. And just continue on with our loop. We will need to push this friend into our friends visited array. Alright, otherwise, we need to go ahead and find out the distance to this next friend's home relative to the position where Granny is at right now, which should be the previous friend that she visited. What we'll go ahead and do here is const distance from previous friend, previous friend distance from home equals distance table. We want to go ahead and get that previous friend here. Const previous friend equals friends visited at the index of I minus 1. If we've come to this point of our for loop, we can safely assume that this array here is populated. So this should not cause any problems. What we'll go ahead and do, we'll get the previous friend's distance from home, and we'll get that from the distance table at the key previous friend. Now, what we need to do, we need to take this previous friend distance from home and the distance from home of our current friend. We're going to apply the Pythagorean Theorem to get the distance from this previous friend to the current friend. What we'll go ahead and do here, the Pythagorean Theorem is a squared plus b squared equals c squared. So what we'll go ahead and do here is const distance from previous friend equals, we're going to take the return value of math.square root, and we'll take distance from home times distance from home, that is the distance from home squared, plus previous friend distance from home times previous friend distance from home. By applying the Pythagorean theorem here, we should get the distance from our previous friend's house to our current friend's house. What we'll go ahead and do here is add that to our miles covered. Plus equals distance from previous friend. Don't forget to push this friend into our friends visited array. That way we'll remember that for the next iteration of our for loop. I misspelled friend here. Let's fix that up here. Alright, let's run this through Node and see what that looks like. And we have not a number. What's going on? Since from previous friend, we're getting the square distance from home. Let's count along our previous friend here. And maybe not that. Maybe our previous friend distance from home. Let's constant log that. And see what that looks like. It is undefined. Now, why is that? We have our distance table here. Ah, yes, we can't use the friend here. We need that friend's town. What we'll go ahead and do here is console.log, const actually, previous friend town equals town's table at key previous friend. And we'll go ahead and reference that in this table here, previous friend town. Let's print that in the node here, see what that looks like. Now we now have our distances, the distances from the previous friend from home. However, we still have this not a number issue here. I wonder why that is. Let's go ahead and console.log our distance from home. Undefined. It can happen that we do not know the town of one of the friends, hence will not be visited. Okay. What we'll go ahead and do in that case then is if type of town is undefined, then we just hit continue and go on with our for loop from there. Let's plug this into Codewars here. 1034. Alright, we actually now needed... We are actually missing something here. We actually need to add the distance from the last friend visited back home. So what we'll go ahead and do here is miles covered plus we'll go ahead and get the we'll go ahead and do this distance table at friends visited at friends yeah, it's gonna get a little convoluted. I have a better idea. It's always a good idea to have clean code. So what we'll do here is const last friend final friend equals friends visited and index friends visited -1. We do this to get the last element of our friends visited array. Const final friend town equals town's table and final friend, and const final friend distance equals from home equals distance table at final friend town. we need to add this to our miles covered here to account for Granny's return home. Plus final friend distance from home. All right, feed that into our kind of not a number. Towns table. Final.
Now, why is that? Console.log. Final friend, town. Undefined. .length.
Code carefully, ladies and gentlemen. Alright, let's try feeding this into Codewars and see what happens. And try to submit it. We've got a problem right off the bat. Expected 889.
No, we're not missing the friends right here.
I have an idea. Instead of getting I-1, let's try friends visited .length -1. Because we always want the last element in this friends visited array. Maybe I'm miscalculating my Pythagorean theorem. Alright, we have the current distance from home. And we have the previous friend's distance from home. We're going to go ahead and console.log that and see what that looks like. So what we're doing here, to recap, first we're going to go ahead and get the current friend of Granny's and that friend's town. We're continuing in the array if that town is not defined, it's not listed, that friend's town is not listed in the towns table. We're going to go ahead and get the distance from Granny's home of that town. If Granny hasn't visited any friends yet, we're going to add that distance from home to her miles covered in this trek we're going to push that friend into the friends visited array, and we're going to continue on with that array, that for loop. Otherwise, we're going to go ahead and get the last friend that Granny visited by getting the last index of this friends visited array. We're going to get that previous friend's town and that previous friend's town's distance from home. Alright, what we're going to go ahead and do from what we went ahead and did from there is we took the distance from home of the current town and the distance from home of the previous town visited, and we're applying the Pythagorean Theorem here. We take a squared here, add it to b squared here to get c squared, and we're going to take the square root of c squared to get our c, which should be the distance from the previous friend's town to the current friend's town. We're then adding that distance from the previous friend to the miles covered. And then to conclude the trek, we are taking the index of the last friend visited in the Granny's trek, taking that town and its distance from home, and we are adding that final friend's distance from home to our miles covered here to reflect Granny's trek from the final town back to her home. Feeding in that into the node with these parameters here, we're getting 1333. However, that very same test expects a return value of 889. And I'm trying to figure out where we're going wrong here. Oh. Okay, I think I have got my implementation wrong here. Let's go ahead and try this. I'm going to bring up this graphic here at the bottom of the Kata. It seems the distances from our towns and the distances from the different distances from x0 to x1, the distances from x0 to x2, and the distance from x1 to x2 form a right triangle. What I think we can go ahead and try to do based on what I see here is we'll take that previous distance from home, square it, and subtract the current distance from home of the current town. Alright, I'm going to go ahead and comment this out here. And what we're going to go ahead and do is const distance from previous friend equals math.square root distance from home squared minus previous friend distance from home squared. Let's try feeding that into node, and we're almost there. Let's try, instead of flooring this, rounding it, running this through math.round, and by golly, I think we got it. We have our 889 here consistent with this test here that was previously failed. Alright, let's go ahead and clean this up here, get rid of the console.logs. Let's go ahead and feed this new solution into Codewars. And try submitting it. And still problems. What's going on now? An approximation. Okay, let's try doing this. Skip the math.round here. And instead return it here. Feed that into node. We still get our 889. I'm going to copy this, feed this into our Kata instead, and try submitting that. Still problems. Maybe instead of math.round, do math.floor. Try feeding this into our Kata. Again, run the tests. That was quite the heavy lift, but finally we are good. Welcome to Versus Codewars. I never said this would be easy, then again I did not come here for easy. I was most well aware of the version of the Pythagorean Theorem for calculating the hypotenuse of a triangle where the lengths of both of the legs are known, taking both of the legs squared, adding them together, and then getting the square root of the sum. However, there's another version of the Pythagorean Theorem that is used for calculating the lengths of one of the legs of the triangle where the length of the other leg and the hypotenuse is already known. Take the hypotenuse squared, subtract the length of the known leg squared, and then calculate the square root of the difference to get the length of the unknown leg. I made the mistake of using the better known version of the Pythagorean Theorem in this Kata for calculating the hypotenuse, when I should have used the other version for calculating the unknown leg's length. And that's going to do it for this episode of Versus Codewars. My apologies this episode ran so long because of that last Kata. If you like this video, or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges from Codewars. As always, if you think there's anything I can do to improve on my code, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.